to another webinar hosted by Seek and Andy Starnes of Insight Fire Training. We have Andy here who brings over 30 years of his experience as a battalion chief in Charlotte, North Carolina. So Andy, thanks for being here with us today to answer some questions live. Should be a good webinar. It's different than anything we've done in the past. So yeah, thanks to everyone who submitted their questions ahead of time. And we will just jump right in to the first one, unless Andy, you wanted to give a little intro.
No, we can go right to it. We can skip all that intro stuff. If they want to know more about me and you, they can look it up, right?
Cool.
Let's give all of our attention to the people who came to this webinar, right?
Yeah, I agree. First, Andy, can you tell us the difference between the Situational FirePro 300 and the decision-making camera?
Well, I've got this cool picture here of the camera side by side. At first glance, we can see that they're obviously smaller, but one of the things that we need to talk about that a lot of people are not aware of is firefighters are guilty of reading specs only. They look at a sheet and it says this much resolution, this much refresh rate, this much thermal sensitivity, and they'll say, well, that's the same as this one. Well, I can tell you that doesn't work out when you put them side by side. A FirePro 300 in performance of the detector is the same as an Attack Pro and performs like many decision-making cameras as far as its performance, the core, the refresh rate, its clarity, all of that. However, if you look at these two pictures here of this giant tractor trailer truck from overseas versus the little smart car, if we visualize the same engine in both and we ran both of them into each other, which one of these would survive? The bigger truck has more framework, strength, stability, and insulation. So when you look at the Attack Pro itself, it's rated for an internal temperature of 250 degrees Fahrenheit for 20 minutes, or 121 degrees Celsius, or 260 degrees Celsius, or 500 degrees Fahrenheit for 5 minutes, internally, not externally, internally. Whereas if we look at a FirePro 300, the internal over temperature warning can only be 150 degrees Celsius, which is 302 degrees Fahrenheit, for 5 minutes, or 260 degrees Celsius or 500 degrees for 1 minute. So the thermal insulation is quite different in both. Plus, if you look at the Attack Pro in the previous picture, or actually I'll show you just through this screen, this one, the lens itself is recessed back due to this cowl or overset or overhang here that prevents a firefighter from striking the lens when they're crawling or moving around. Doesn't mean they can't do it. Whereas the FirePro 300, the lens is up front, it's easy to wipe, but it's also easy to strike. So there's a big difference in the durability and the thermal insulation of both devices. When we look at situational awareness ticks in general, many other models are much lower resolution, as you see in the picture here, the 9 hertz models on the left, and they're also 1/4 of the resolution, they're 19,200 pixels. Whereas if you look at the ones on the right, they're as low as 32,000 pixels to as high as 76,800 pixels, which is the FirePro 300. So they vary in their actual performance, even within the situational awareness ticks themselves. What keeps the FirePro 300 from being rated as a decision-making camera is simply the durability and insulation factor and the screen size itself. And we pull those standards from NFPA 1801, even though most cameras do not meet NFPA 1801. We look at the specifications because NFPA 1801 has some of the most intense, detailed descriptions of what a camera should be built or how it should be built, how it should perform, and why. So make sure you look at these devices in a fire, test them. We'll talk about at the end of the webinar how to test them. And where we get our decision-making tick criteria from is from NFPA 1801, which is within the NFPA 1930 standard now. Many NFPA standards have been consolidated. And that consists of 320 by 240 resolution, 25 hertz refresh rate, TI basic color palette at startup, minimum screen size, over temperature rating of 500 degrees internally for 5 minutes, and many other factors that many people never read. So one of the things I'm challenging the fire service to do is do your homework. Get online, pull up the documentation, put it in your hand, print it out, read it. Because if we're only going to get our information from webinars and Facebook or whatever it may be, that's surface level information. Do the homework, read the research papers, read beyond the specs, and then take this and test them to see how they actually perform. You will find that 320 by 240 resolution side by side in many cameras does not look the same. And that has to do with a lot of factors, that firefighters don't understand until they actually start doing their homework about how the image is formed, what the screen does, the image processing, and how it performs in a fire. So the main difference that we just focused on is the thermal insulation and durability. All right, let's move on to question 2.
Okay, awesome. And before we jump to question 2, I did want to preface, if anyone didn't have a chance to submit a question ahead of time, feel free to drop a question in the question box and we can see how many we can get to at the end. So just wanted to mention that real quick. Question 2 is kind of a 2-part question that we got asked. So the first part is, what do thermal imaging camera manufacturers think about wiping the lens with a glove? And what do you recommend is the best material and or specific product to do this? Also, have you ever pre-attached one to your TIC for use?
Well, this is a very common question. If you listen to certain manufacturers, they'll tell you not to wipe the lens because you will scratch it, which is counterintuitive to what we do, because if the lens gets blocked with moisture, insulation, or debris, the firefighter will lose image clarity or not see at all. So in order for an image to be formed, that lens has to be unobstructed and clean. Well, the problem with that is where a firefighter is going. They're going in an IDLH environment that is not clean, dynamic, moving, debris, smoke, moisture, and moisture is kryptonite to fire service thermal imaging cameras. So that lens has to be periodically wiped. Now, those that say, like the instructions here, say you should use a cotton ball or lens tissue with 96% isopropyl alcohol, this is not practical in a fire. No one's going to stop and do that. If you try to put a cloth or something of that nature on there, that cloth will be extremely dirty by the time you get there, and you're not going to have the time to pull a cloth out of the pocket and wipe every time you scan. Because we recommend scanning at every threshold as you move into another space. So a 4-room compartment, that's 4 scans minimal, you're talking about adding a lot of time, and you're going to drop it, or if you have it attached to you, it's going to get dirty. So we have not recommended having a cloth or anything pre-attached to it, because it's just going to get in the way, could block the lens, could fall off. But on the other side of the coin, you need to realize that firefighting TICs, lenses on these are different than industrial cameras. Industrial cameras or more expensive cameras tend to have a premium lens that does not have a coating on it to prevent scratching. If you look at many fire service lenses, they are black or dark in color because they have a diamond line coating on them. Those are scratch resistant, not scratch proof. I think the biggest epiphany that most fire departments are not aware of is that when they buy fire service thermal imaging cameras, they need to budget for batteries and replacing lenses when they are damaged. The 2 things I see damaged consistently are the lens and the actual screen itself, just because of the environment firefighters work in. Fire departments who think that firefighters shouldn't break them because they should be more careful need to go back down that hallway and look for people in the dark and realize all the things they can run into, and there's no way a firefighter can keep that camera from not bumping into something. So the device itself is durable, but it will get damaged at some point because of the nature of the environment firefighters work in. It's dirty, it's inherently hazardous and dangerous to your health, and you can be injured or killed doing it. It says so on the instructions or the tag on your coat and your helmet. So understanding that the camera should be cleaned when you're done with it, using a non toxic soap, something that's like a dish soap, and then clean the contacts in the lens with an alcohol wipe. Yes, you should do that at the end of every time you use it, but during a fire, that's not practical. It just does not. I've seen trainers try to recommend that, and I'm sorry, it's not practical. You go through a window, you go down a hallway, you're on a hose line, you're coming off a ladder. It is not a practical application. You need to look at what fire service TICs are meant to do, and that fire departments need to budget for lens replacements and put that as part of the line item cost when they're buying these devices, or buy enhanced warranties on them to account for that. And that comes with education and training about the device itself. All right, does that answer the question, Ms. Jordan?
Yeah, perfect. Thank you.
Let's show a quick video of why it's important to wipe the lens. This is a flashover container, and flow a little bit of water, demonstrating a thermal rebound, how short burst cooling is not effective as many think it is. It cools gases, but doesn't stop the surfaces and the heat from radiating back at the firefighters. This image starts to degrade, and then we start to see gray, white. Almost many people would think the fire is going out. This is moisture building up on the lens. We wipe the lens and the image clears up quite quickly. The disadvantage of this is that it will fog right back up because of the environment they're in. So this has to happen periodically. So dirty firefighting gloves, wiping the lens, yes, could eventually scratch the lens. Yes, it can. But you have to consider the alternative. Not being able to see, injury, missing victims, missing fires, potentially killing firefighters, or a scratched lens. I think we need to understand the nature of the job a little bit better before we try to say that this product cannot be scratched or damaged, because it is going to get damaged just like any tool that goes in that environment. So that is the importance of wiping the lens. I reviewed 9 Maydays 2 years ago that all had to do with firefighters failing to wipe the lens. They were unaware that they should do that. So it's imperative, it is critical, it is part of our scanning technique that we teach. See if I can move this forward for you. And on to question 3.
Cool. Question 3, someone said, when should firefighters begin cooling the thermal layer using the go, no-go model? Should anything above 150 degrees Celsius, so the yellow color, should that be cooled during the fire attack?
Well, that's a great question. However, the absence of color is not the absence of heat. And if we're waiting on color, we're too late. The go, no-go decision-making model is one of the most misinterpreted models introduced by Project Kill the Flashover, and it's quite simple in its description, but quite complicated in its application. It is 4 key things that firefighters need to look for. If they see any of those things, they should deal with it. And we broke them down into a simple model of extreme temperatures or overall level of heat. That means not the spot temperature. Firefighters need to remember the spot temperature is not accurate, and it's a small measurement of a surface wherever it's pointed. We're reading the entire color palette, fast moving convection currents, or high velocity smoke, as it says in the little black dot there. We're looking for a thermal layer that is descending greater than 50% of an overall space in a residential context, or a collapsing neutral plane. You need to understand a neutral plane is quite different than a thermal layer. A neutral plane is a difference in pressure between exhaust and an intake that's visible at an opening. And many times neutral planes collapse at an angle due to pressure, so they can be quite deceptive. Thermal layers, on the other hand, can be deceptive as far as firefighters failing to recognize them. If they're not recognizing grayscale, or that white line that separates the hottest area from the coldest area, they may not cool adequately. If they see fast moving grayscale convection currents and wait till see color, they could be late. There's many reasons why you wouldn't see color, like you're too far away from it, the surfaces have already been cooled, it hasn't heated up those surfaces enough to colorize. So in general, we shouldn't wait for color. Yes, we should cool based on the model itself, but need to understand that this is a thermal diagnostic model. It's not used for gauging structural integrity. It's not a survivability profiling model. It is a rapid fire development model. And it doesn't mean never go. It simply means we must mitigate the factors and variables that we see that will cause thermal insult or lead to rapid fire development before moving forward. And there are far too many variables to have a one absolute model that guarantees success or injury prevention in an ever-changing fire ground. It's just not possible. I think people want an exact answer, exact temperature, and an environment that changes every single time due to layout, vent profile, hallways, fuels. There's too many variables in that. What is the same is when a fire burns, it produces heat and smoke. And we have to understand that the device we're carrying, number one, is not a thermometer. The absence of color is not the absence of heat. Using an incorrect application mode can cause you to either not interpret the environment properly or misinterpret it by saying, oh, that's hotter than I think it is. This is an example of survey mode looking down a hallway. Well, survey mode colorizes at 150 degrees Fahrenheit or 65 degrees Celsius, which is much lower than TI basic. But if someone was misreading this or misinterpreted by looking at the spot temperature, they would simply say, oh, it's 97 degrees, we're good. No, it's not 97 degrees. Anyone who's taken our training understand that these are not thermometers. They can be off by several hundred degrees. The spot temperature was removed in 2021 from TI basic due to listed as a contributing factor in numerous firefighter line of duty deaths, and it's been a contributing factor to rekindles and misinterpreting like this. The other thing is fire service ticks should not be used for certain incidents because of that, such as lithium ion battery incidents. There's been numerous close calls where firefighters have used this and simply looked at that spot temperature. And the Surprise, Arizona incident is one of those where they were catapulted 73 feet after reading 104-degree spot temperature. These are not X-ray vision. They don't read gas temperatures. And if you're using old antiquated models or smaller, lower resolution situational awareness ticks, you shouldn't do that as well. We need a high resolution, fast frame rate, TI basic color palette that shows us extreme temperatures, where is the heat, where is the thermal layer, how fast are the convection currents, what's the height of those convection currents, and we need to deal with that in each space. And it's not an exact number. It's if I see that, then deal with it. So if you're just looking for color, you're in trouble. We need to look for convection. We also need to look for fast moving convection or that descending thermal layer. And we also look at high velocity smoke. Everyone was taught to read volume, velocity, density, and color from Dave Dotson. I wish he would have added volume, velocity, density, color, and heat. Many people like Shannon Raphael created the Be Safe model. A lot of innovators all have very similar decision-making models. And if you break them down, they're asking you to look at the very same thing, but none of them, with the exception, I say Shan, included a tick in there because his included heat. So look at heat, you have to have a camera and you have to interpret it correctly. And this is the model exploded, broken down. I mean, 4 parts blown out for you. We have a 50-page manual in our Train the Trainer that breaks this down. And the reason why KTF chose a 500-degree mark had nothing to do with survivability profiling. It had everything to do with the fact that that's when the majority of firefighter PPE began to fail per NFPA 1971. Well, if we looked a little deeper than that, well, would you want to wait till the failure point to engage? No. So we added a class 2 thermal environment, which is 300 degrees or above, as you mentioned in your original question. Because if you look at the overall fire environment versus your PPE, unfortunately, not every piece of PPE is rated exactly the same. Your turnout coat and pants are very durable and take a lot of heat, whereas your face piece, depending on how well it's kept, what age it was bought, cannot. What type of hood are you wearing? Your radio does not take heat the same way. Your SCBA, the cylinder, takes an extreme amount of heat, but that regulator line coming to your face piece can heat up quite quickly. So understanding why thermal data is important in interpreting properly and has to be visible in the tick allows you to say, that's hot. I'm not looking for an exact measurement. I see convection currents, or I see color, or I see all the above, and I cool where I'm at and cool where I'm going before I get to that space and make sure it looks like this. I need a thermal layer to rise or neutral plane to lift, which is what my friends overseas teach in CFBT tactics. They look for that thermal layer or neutral plane to lift. The neutral plane is what they look at majority of the time. I want to reduce overall temperatures below 200 degrees. How can I do that if I can't use the spot temperature? Quite simple. Dual gain cameras, the majority of them do not switch to low sensitivity until they hit a 200 or 300 degree mark. If I can cool that environment and kick that camera out of low sensitivity, the triangle goes away, that's a good indication. In a Seek, we don't have a triangle. So if I can make the color go away and the convection slow down or stop, then that's my indicator. I don't want to pass visible fire. I don't want to pass superheated areas. And I want to see the velocity of the smoke and the convection current slow. I am not going to stop them until I get to the fire room. Too many people look for, well, I saw this one temperature point. No, a single candle flame can be over 2,000 degrees. That won't kill you. The overall environment with heat flux, where we talk about rapid heat transfer, that's what's getting firefighters. They're not understanding that that moving smoke that's hitting you is a convection oven. NFPA 1971 talks about a forced air oven test, where they test your gear in 200 degrees or 212, 320, 500, and above 500. Look up Michelle O'Donnelly's work in the NIST paper on thermal classifications for electronic equipment for first responders. She was the innovator behind that, in my opinion. Now they're into UTEC, and they took the thermal classification models and went from 4 classes to now we have 3 ranges of emergency range, which I'm not a fan of. I think beyond 500 degrees, fast moving heat transfer, firefighters should deal with it and not sit there and take it, because that's where firefighters' face pieces are failing. And firefighters need to understand that between 2 to 4 millimeters thick of polycarbonate is what separates them from rescuer to victim. And if that piece of polycarbonate is constantly being heated and you're not cooling or slowing the heat transfer to that environment to you or your gear, you are cooking. And it's only a matter of time till you run out of protection. This model was designed for that, to prevent firefighters from taking thermal insult and stopping rapid fire development. That's a 3-hour class in about 8 minutes. So I hope that satisfies the question. If they'd like to know more, we have this on our Patreon channel where we have a go, no go webinar as well. All right, Ms. Jordan, on to question 4.
Awesome, thanks. Question 4, someone asked, you have 2 hours to train your department on TIC usage. What would be the key learnings to teach and how?
This is my personal favorite question. I get this all the time. Hey, I'm teaching next week in my department. They're giving me 2 hours to teach. I'm like, just go home. They're like, what? I'm like, if you had 2 hours to teach your daughter who's never driven a car before, which my daughter just turned 16, and that's all she got, would you feel comfortable letting her loose on the highway? Absolutely not. I have no idea why the fire service continues to minimize training, not just in thermal imaging, but in every skill set. They continue to diminish the amount of time they are given because of the standards, the time, the training academy is being reduced. We don't have enough time on the schedule. We can't pay overtime, whatever it is absolute heresy. If you understand what a licensed thermal imaging professional has to do just to look at a building and they don't die in that building, it's quite scary that fire departments do this. And I understand that this happens, and I'm going to help you. I'm just venting a little bit as this fire is down that hallway here in China. But I have a webinar here we did from TIC on we did from SEEK on TICs on training academy guidelines, things that can help you. And what I recommend doing is, if you're going to do 2 hours, make sure it's 2 hours that introduces them to 4 key areas based on the existing standards. It doesn't have to be a deep dive, or as my friends in certain groups call the nerd to know language. We want it to be relevant to their job. And here's the 4 things that I recommend that we should do. You need to basically train them on the basic operation. That's turning it on, scanning techniques, carrying it, all of that, which people gloss over, which they end up messing up, and then proper interpretation of thermal data. That is a huge one. Most firefighters misinterpret that data, and that's listed in NFPA 1010 for recruits now. Chapter 7, brand new firefighters shall have requisite and maintenance knowledge of that device. That means they know what that device is telling them, how to carry it, how to scan with it. And they know how to wipe the lens. Then they need to know the contraindications. I wish the entire fire service would just do point 2. That would stop a lot of the problems we have, because currently fire departments are using TICs on everything but fire. They're using them on hazmat incidents. They're using them as thermometers. They're trying to use them on lithium ion incidents. And I'm like, whoa, slow down. There are specialized devices for specialized incidents. These devices are designed for fire. These do not measure gases. They don't see through things. They definitely don't provide accurate measurements of temperature, but anecdotal information is passed on, and fire departments even are guilty of trusting certain things that are written in instructions, which have led them astray. I've read 2 sets of instructions that say this device can be used for accurate temperature measurement. I'm like, no, it cannot. Let's take that, put it to the test. So contraindications of the device, where it will not work. Listen closely. If you go into a cold smoke environment, a sprinkler head discharge, high moisture content in a large space, a fire service TIC will frustrate you and possibly get you in trouble, because they do not work well in ambient temperature environments and high moisture content environments. It stops or reduces the amount of IR radiation coming to the lens, and then that builds up on it, which gives you nothing to detect, recognize, or identify. Which leads me to what I believe is the most critical point that firefighters should do once they have basic requisite knowledge on operation interpretation and contraindications. They should be able to identify 2 things, 2 key areas: what objects look like, which include people, by the way. I know people are not objects, but that would be things like cribs, beds, hose lines, stairs are critical, windows are critical. I can cite numerous Maydays and line of duty deaths where this is mentioned. One that just got brought to my attention today, of being able to identify a window, identify things like a panic bar, on a commercial door that is made of metal. Because of emissivity, it sticks out. They can see that. Floor registers or ceiling registers that are typically above or below a window. Identifying those things can help firefighters maintain orientation, find areas of search priority faster. And then we talk about hazard identification. What does high heat conditions look like? What do convection currents look like through my device? Because, ladies and gentlemen, they don't look the same on every camera. They don't. Due to programming, the type of device, the sensor, processing, and the firmware they use, they look different. What does the color look like? When does the color engage? How far away do I need to be? Which is talked about in 1408 about distance to the target itself and how that affects you. And then the last thing I would do with them is show them how to use it tactically. And you're like, why would you do that last? Because Kyle Romga said it best. Everybody wants to go straight to skill acquisition, and we haven't even read the instructions yet. And that is our problem. There are 3 existing standards on this screen, and 40% of the fire service doesn't even know that these apply to them, and they're going to be held liable for. I hear fire departments all the time, we don't do that. Gentlemen and ladies, I like the phrase cafeteria Christianity. If you're going to go through this and choose a few things you like and discard the things you don't, when it comes to this, when we go to court, when somebody gets injured or killed, they're not going to care that we chose not to follow a particular standard. They're going to say, what was the best consensus standard? What do these professionals say? What does your tactics, your policies, everything say? And if you don't do that every time, they're going to hold you civilly liable, potentially criminally. And when we kill a recruit or a brand new firefighter who gets a tick in their hand and they've never been trained on it, and I met a department recently, 1 year after they've been on the job, they could be riding the seat and they haven't had these 4 key areas, litigation and tragedy will spur regulation. And I don't want to see someone lose a loved one to make that happen. So we created a very simple 1-hour webinar, and we teach this in our 4-hour part of our 8-hour a day on these 10 key things. And they're very simple. They are not a deep dive into thermology or thermography. They are experientially relevant, blue collar PhD, simple things. And if you think this is really simple, I wish it was, because they don't do this. Number one, we don't over rely on technology. We harp on that. Why it could fail us, what could happen, and how we could misinterpret it, more importantly. And you know, the biggest obstacle in all of these 10 things listed here is number 2. They don't carry it. I ask every class, how many of you carry the device 100% of the time, every time you put your turnout gear on? In a room of 20 to 30 people, usually 1 to 4 hands go up. So that means 90% or 80% in some cases of the fire service is not even carrying the device. So if we're not carrying it, we're not even, this is a moot point. So we got to get past this. We got to learn to carry it. And then when we turn it on, it takes a full 30 seconds for any of these devices from power to ready to work for them to be ready to go. It may say 5 seconds, 10 seconds, 17 seconds, but if you turn it on, you'll realize really quickly it goes through a process called flat field correction. It freezes, it clicks, it is warming up and adjusting to that environment, and it's not ready for business until that full 30 seconds hits. Point 4 is what you asked about. Where are you getting your training? Is it anecdotal? Is it out of a textbook that has no prior training in thermography whatsoever? Do you know there's not one currently? So we have the only standardized collegiate-based certification in that because of that. So where are you getting your training? Are you looking at the NFPA standards? Are you looking at industrial standards? Are you going outside of the box? Because if you're just going with whatever Jones and Bartlett says, good luck. And then point 5 is probably the biggest thing, 5 and 6, we see messed up on the fire ground consistently and hear about is scanning. They don't scan properly. I was taught to scan high to low. I used to teach scan high to low until I realized scientifically, behaviorally, and from a thermography standpoint, that's a bad idea. We start our scans low and work up from the lowest level of hazard up and for where victims are found. We teach them to wipe the lens, the importance of it. We show tick failure by creating an environment where wiping the lens doesn't work well because they're in a flow path or high moisture content environment. We teach them to interpret the data that they see, which we'll talk about in the Max Firebox. We teach them additional features such as investigative mode color palettes, which are a huge benefit from firefighters, whether it's survey mode and SEEK, search mode and FLIR, or electronic thermal throttle and Bullard. If you're not using those, you are missing out. That's like buying a car with a ton of features on it and you just drive the car and you never turned on the heated seat. Why not? You paid for it, use it. And then know the limitations. Every firefighter has limitations. What are the odds an electronic device with a lithium-ion battery could have a limitation? Then, after all of that, we start doing size up, making entry, search, fire attack, and ventilation. It is not a simple process, and the fire service needs to get on board with training their firefighters to do this. We spend 32 hours in our train the trainer covering these 10 things. And we've got 2 simple webinars to help you with that, sponsored by Seek. What the camera sees and what it doesn't see in Thermal Imaging 101, and these 10 things broken down in a 45-minute webinar and the Tips for Success webinar, which is the basis for our teaching. All right, Ms. Jordan, on to question 5.
Okay, question 5. What are you thinking about ticks from China?
Well, I got to give a shout out to my friend Howie, because many of you know we just got back from China not too long ago. I would tell you that before you travel to China, please look at that line called the equator and see how close where you're going in the time of year. We didn't do that very well. Our first day of live fire was basically 115 on the heat index and an 80% humidity. I don't think we stopped sweating the entire time we were there. Incredible people, incredible training facility we visited in Sanming, and we got to experience and play with different types of thermal imaging cameras made in China and China only. Some were impressive, some were not so impressive. I was very impressed with the mass-mounted ones you see my guys testing out here. That is the first mass-mounted tick that I actually liked because it actually worked and it had a 30 hertz processor on it, which allowed them to scan and keep up with it. However, the thing that I see consistently done, not just by the Chinese, but a lot of other manufacturers, is they're putting a lot of non-fire based color palettes in these devices, such as rainbow, iron bow, fusion, they may call it the Arctic or medical type color palettes where they're purples and yellows that become very intense and oversaturated in high heat environments. I think the Chinese have a benefit on as far as high gain. I saw better detail in their cameras in high gain than I've seen in many cameras. However, that when they went into low gain, many of them experienced problems, froze, could not handle heat very well. So like the one on the end, the thermal cam there, F1, that was much more insulated than some of the other ones. But there were pros and cons in all of them. But I'd say in general, they need to work more on the color palette applications. They need to develop their own standard, and they need to not focus so much on thermography based applications, such as, you know, they had everything from adjusting the emissivity on one of them to variable, like lots of buttons you could press. That doesn't happen in a live fire environment. You're going to press the button once or twice, that's it. So I think that's part of it, is they're building industrial cameras for fire purposes, and that they would do well to have a fire consultant help them with that. But I would say that the mass mounted ones we wore had the best image clarity. I wasn't real crazy about the mask, as you can tell there. It's kind of an odd shape. It didn't fit my head, and I got a big head, but that might have been part of the problem. But we had a great experience, and as if you see behind them, there's this massive screen. And when we were wearing this, this was transmitting wirelessly to the screen. So it's quite impressive. So there was a lot of pros and cons, like I say, about many cameras, but I think the biggest thing that Chinese ticks have to work on is their insulation, their low gain, and color palettes. Those would be the 3 things that they definitely would be well versed to improve upon. So, all right, on to question 6.
Thanks for touching on that. Question 6, someone asked, what would you consider, the minimum training for tick use?
As you heard me preach about earlier, I am not a big fan of the words minimum. There is no minimum training in any skill set. And one of the things I'm not a big fan of in the fire service is we set certain hours on things and we say that's enough. Well, in general, there's this phrase called certified versus qualified we'll talk about here in a minute. But if you look at what standards currently exist and what's not being done, it should keep you up at night. NFPA 1408, the thermal imaging training standard for the fire service, requires every firefighter who is affected by thermal imaging use, if you have one on your apparatus or you will be using one or someone will be directing you through one, that you shall have classroom hands-on and live fire training in up to 23 topics annually. Our 32-hour class doesn't cover 23 topics. And then if you look at people who do this for a living, who do not go into IDLH environments, there's only a couple environments that I've studied who are licensed thermographers who are actually in a dangerous environment. They require a minimum of 32 hours of training for a level 1 thermographer. And there's 3 levels of that training, which puts you at 96 hours. Then there's specialized certifications for mostly non-hazardous use. There are some crazy ones like people who fly high voltage power lines and work in high voltage power lines, or optical gas imaging, working in high risk explosive environments, furnaces, and things of that nature. What we recommend is that every firefighter have a baseline training, which is what we wrote in the program with WKU and Kentucky Thermal Institute called Tactical Firefighting Thermology, which requires a 10-hour base level training plus a 1-hour max firebox video they got to watch before they actually go do something. And we do that on purpose because some of these terms have been misinterpreted, mixed up, said incorrectly from manufacturers to instructors. I've even mixed them up when I first started doing this. So we wrote this curriculum and we had it peer reviewed. Why did we have it peer reviewed? Ladies and gentlemen, I'm not smart enough to risk your life on my opinion. What if I make a mistake? Is that good enough for you? Oh, I got errors and omissions insurance. No, that's not good enough. So we had other experts look at what we wrote, and then we had the college credential it on top of that. So in the presence of many counselors, there is success, is what I believe in Proverbs. You got to understand that if you don't have wise counsel looking over your program when you consider minimum training, you're gonna have a problem. I think to rephrase your question, I would have a certain amount of training per role-based operations level, like recruits get this much training, firefighters get this much training, company officers get this much training, and hear me when I say this, command staff get this much training. Special operations division gets another level of training. And you know who gets the most training? That would be your instructors, your R&D division, and procurement. Because if they're buying it, they should be experts. If they're training people on it, they should be experts, and they should be getting continual education that's revised and updated. So that is from the time you're hired to the time you're retired, a continuous education model, which we talk about on our 4th day of our Train the Trainer, where we make them the instructors, and we talk about implementing this into their department and how challenging that could be. But we give them a phased implementation approach. So if you say minimum training, I'm saying, well, who am I giving it to? Recruits, I'm giving them 4 to 8 hours. Company officers, I'd love to give them 16 hours or more. Operations-based personnel, I'm going to give them a minimum of 8 hours. That's what I would recommend, because if you look at the amount of time it takes to do the classroom discussion, a small scale prop, and a live fire evolution, that's 8 hours. So it takes a lot of time because we can't just go from one to the other. So my recommendations are recruits get 8 hours, operations gets 8 hours, company officers get 16 hours, command staff and special ops go anywhere between 16 to 32 hours, depending on their role and what they're doing. But that's would be the minimum I would give them. And anyone who's serious about this would go to a level 1 thermography school and realize, oh my gosh, there's so much more to this. So please get more education and training, because you can never learn enough about a job that can take your life. This is an example of NFPA 1408. These are the 23 topics that they list you should be trained in. I want you to look at this list with me. Search, fire attack, investigations. Wonder who should be trained in that. Overhaul, motor vehicle accidents. How are we using that? Are we using it correctly to identify thermal latency of how long someone's been in the seat, skid marks going off a road, heat signatures underneath the car indicating how long the car has been there. Size up. One of the most critically important ways a camera can be used. We can spend a total of 3 days just on this topic alone, using building science principles from thermographers to teach firefighters how to find the fire, hottest part, coldest part, and read infrastructure of certain buildings. Hazardous materials incidents is a different animal. You can't see gases, but you can see the effects of certain things, whether endothermic or exothermic reactions, spills, and many other things. Electrical emergencies is probably the most underused area that it should be used for. You can see heat transfer from many different objects that could prevent firefighters from being electrocuted every year. USAR operations, there are specialized cameras for that, for locating people, drone use and SUAS and UAS, RIT training. I got a lot of friends who do RIT training. However, I don't see a lot of them doing tick training in it. They're monitoring people with tick training, but they need to learn there's so much more you can do with a tick for the purposes of locating, assessing, and getting that firefighter out of there faster with that data. Accountability, where's my crew, where are they going? Rehab, cumulative heat saturation. 7,500 firefighters are burned in training each year. In training. Wonder why? Wonder what you could see in flashover containers, standard live burns before someone's burned. If you know how to recognize and interpret heat, you could see the amount of heat they've been taking and know they need to come outside, take their gear off, allow it to off gas, despite how much time we don't have, which also affects participant safety. My truckies, ventilation, this could be outside vent, vertical vent, being able to identify areas that need to be ventilated and cutting in the right place, no different than stretching the line the right place. It's important to do so. Apparatus placement in wildland incidents and high smoke environments. Stream placement. I'm an engine company nut. If you're not flowing water in the right location for the right duration, we're just scream and shout, spray water all about. Exposure protection is something that's often overlooked. Don't wait till the building starts smoking to realize you're too late. You can see that on the camera. Water rescues, depending on the camera, specialized application features. They can identify people bobbing on top of the water, not under the water. You can't see through it. You can definitely use it to help our law enforcement brothers and sisters. Wildland is out of everything listed here. This is probably the most underused area at all. Wildland firefighters take a beating, and they could be using it so much better. Building construction, pre-planning, inspections, identifying types of construction, and training obviously is huge. And I highlighted the last one, which is the most important. What area does your fire department need to focus on that's not on this list? And why aren't we doing it? That is your overview of NFPA 1408. Question 7, Ms. Jordan.
Question 7, someone asked, what's the difference between a good training program and an excellent training program, and how valuable are Max Firebox trainings versus live fire trainings?
Okay, well, let's talk about good versus excellent. Who do you want coming to your house? Certified versus qualified. I took my Firefighter 2 certification at age 16. I was certified. Does that mean I'm qualified? No. Written tests do not test your actual practical skill knowledge. So I think an excellent training program uses practical demonstrations and drills that require the individual to interpret and explain the concept and be graded upon it. Not like pass, fail, but they don't understand it, fix it right there. It's called a teach back. I teach you, I share information with you, I constantly measure how well you're absorbing that information as we move through the process. And at the end of the training process, I let you teach me. I'm not preparing you for a test. I'm preparing you for a position. It's been my motto for years in helping people in promotional. I'm not trying to help you pass that test. I'm try to help you get ready for the challenges you're going to face. And if we're not making those scenarios where they build upon each skill, where they get more competent, get more confident, and it's experientially relevant to what they do with their staffing, with the exact model they use. You don't train them on a XYZ brand camera and they don't use that camera. That's a mistake. And it has to relate to those tasks and objectives that are used in a fire environment or emergency situation. Now, we can't obviously do everything, but we can simulate a lot of things as long as we have heat. Probably the biggest thing that I see that is not done, the first word in TIC, is thermal. And people are not using heat, using fake smoke and heated mannequins, which produces a false positive. If you take our search class, you learn the 3 variables that affect how a victim will present based on the camera: background temperature, body temperature, and the camera itself. Huge problem in the fire service. People are waiting until they see a white hot victim. You're seldom going to see a white hot victim. They may appear white if they're remote from the fire or if they're on fire, but those variables are not taught because we can't use live victims in fires. At least we're not supposed to. Hint, hint to those out there. Failure and disorientation shall be demonstrated in your training. Show them the device failing. Show them an environment where it doesn't work well. A sprinkler lab is a great one if you have one of those. And emphasize fundamental skills, regaining orientation without the device. To me, I think when you wrap this all together, with what we call crawl, walk, run teaching mindset, where we have a classroom, we have some small scale demonstrations, which we'll talk about here in a minute, and then take them into the Class A building to get them more confident by increasing their competency level and their level of understanding. Then we have an excellent program, because what makes a training program excellent is not the instructor. It is the caliber of the student that comes out of that program and how well they can turn around and share that information correctly, and yes, better than me or anyone out there. Because if we can train firefighters to be better than us, to understand it better, and to even teach it in a way that just blows your mind, that's an excellent training program, because they are going to help people in ways that you and I could never do. So let's start grading our training by how well our students can actually take that information and apply it. And if you're not measuring that, then we're missing the mark. So understand that first with good versus excellent. And when it comes to Max Firebox, I've been using the Max Firebox. My best friend, amazing person, and business partner, Sean Blockner, from 2015 to now, we have seen smiles and more understanding with a small scale prop that has helped us long before we went into the burn building, because of a very simple factor that most people don't think about. It's called the face piece. Once we put the face piece on and we go in the burn building, not all of us have clear, beautiful voices. We sound like Charlie Brown's teacher. Those of you who are old enough to know what that means. We're very muffled. We don't convey our point correctly. We can do these demonstrations outside with various cameras and do a lot of the concepts that they saw in the classroom before we take them into that environment. And we can actually let them try it. Hey, try your scanning. Look for high and low sensitivity in a dual gain camera. Let's look at convection currents in this camera versus that camera. When do we see color? Let's do a distance test to see how far away you can get from this device when you lose color, when you can't identify a small hand. Hey, let's stand at the side of this thing. It's diamond plating. It's blowing 2,000 degrees out of the box, but the spot temperature says 70 degrees. Why is that? Let's talk about emissivity. Let's talk about those variables while we can talk about them and answer those questions and correct any miscommunication, because we all miscommunicate, then take them into the building. This is the step between the classroom and the burn building that is often overlooked by many fire departments. Whether you use a Palmer dollhouse or any type of wood prop, or you use the Max Firebox, which we use, we have 3 of them. It is critically important that you use a small scale prop, or as you read the book, The Talent Code, look at the section he talks about called deep practice. This is a part where we've been exploring for a while. Unbeknownst to me, we were doing it. We didn't know we were doing it. Now we're going to do it better, of taking things that are not considered actual practice, but practicing in a way that helps them understand it. Then we go in and look at the fire differently. This QR code on the left, the instructional info, by the way, this particular webinar, you're going to get more resources than we've ever given away, has an outline, how to teach with a Max Firebox, how to teach with a Palmer dollhouse, how to build a Palmer dollhouse, not the way most people build it, the way we recommend. And then you can go to Sean's website and check out the Max Firebox. Nobody's more passionate. Nobody gives more heart into the fire service than that man. His mustache has a heat signature. Check it out on the tick. He's an amazing individual, works harder than anybody I've ever met in my life. And I'm blessed to know him and have him as my friend. But I will tell you, that prop right there can really change people's opinion about fire behavior and tick. Just make sure you do some kind of small scale demonstration before you take them into a fire. Question 8, Ms. Jordan.
Question 8, we had someone say or ask, my department is planning a tick evaluation. We have a few different ticks we will be evaluating, but I'm not sure which ones. What are 5 simple things I should ask our evaluators to compare while burning?
I'm not sure why we get to choose 5, but I would definitely break it down for you. First of all, evaluators need to be trained before they can evaluate. If you just give them a camera and say, go tell me what you think, bad idea. So are your evaluators trained in thermal imaging and how it works, requisite operational based knowledge and the things we've already talked about? And then do they know each of those cameras as far as the specifications that are listed on paper, when it's supposed to show color, when it's supposed to switch to low sensitivity, is it mixed gain, is it single gain? They need to know that now. And then they do need to do that small scale prop before you take it into a container. And here's what I recommend. We give this away, ladies and gentlemen. First, evaluation criteria. This is on our website, tells you what to do. Okay. Then we have a tick evaluation webinar that explains to you how to do it, sponsored by Seek Thermal. Even though you may not be buying Seek, Seek's very focused on education of firefighters. And then I even wrote it out in an evaluation document on the steps of what you need to do. 1, 2, 3, not 5, 3. But let me tell you, it ain't simple. And here's what me and my company recommend you grade and how to simplify it. 4 key points to start with: image quality, speed, simplicity. Can I operate it with gloved hand? And durability. If it doesn't do those, don't worry about the bells and whistles. It's not going to work. It's got to provide the best image in the worst environment, in low, moderate, and high heat environments, and you need to grade it. It's got to keep up with you. It has to have a good refresh rate. And some say certain speeds, some say higher speeds, but that doesn't mean anything until you go in the fire and see how it's actually processing that image. Because sometimes 60 hertz is not 60 hertz. It may say so on paper, but when you add things like gain change, firefighters scanning improperly, bad idea. The criteria, though, that you read about that we grade is field of view, how well we can see based on, is it narrow, wide, convection, current identification. Can I identify where the fire is when there is no color? Target identification. How well can I see objects and hazards like chairs, hose lines, door frames, windows? And colorization. When does it show color? And can I see through the color to tell that there's a door behind the color? Does the color completely block out detail? Does it offer a lot of colors that I shouldn't even focus on? And by the way, in my opinion, you should only do these grading in TI Basic. Do not grade the bells and whistles, the TI Basic Plus features, whether it's survey mode, whether it's all that. If it doesn't perform well in TI Basic, odds are many of your firefighters will never go outside of that basic application mode without proper training. So those are the key things. Is it a great image in bad conditions? Is it fast? Is it simple? Is it durable? And does the following criteria fall into your ability to interpret that data better? Is there a wide enough field of view to see the environment? Can you identify convection currents easily? Can you identify targets and hazards? And how does color affect you in it? Is it easy to identify? Is it hard to identify? Does it provide information or does it hide information? It's a question you should ask. All that's broken down in these 3 QR codes. Please do not just look at this, scan it, look at the information, watch it, read it, and apply it. And your evaluators, point 1, should be trained before they're allowed to evaluate anything. They cannot appreciate an innovative product without an education. I'm sorry. If they're not educated in it, you're going to get a very interesting opinion. It's not going to be an educated opinion. It's going to be an opinion. I want data. I want experientially based reviews from people who are trained and educated in that area. And your evaluators should also be your TIC instructors, by the way, which is very few across the US, I'm finding. All right, Jordan, question 9.
Question 9, it says, you are the first arriving engine company. How would you implement a TIC, and what would be the top 3 things you would prioritize for using a TIC?
I think this is my favorite question out of all of them, because I think this is things that we ask our trainers at the end. I ask every group, well, I do it in any class. At the end of every class, I ask them, what's one thing you're going to do if you went to a working fire today? By the way, the last 2 years of classes, we have taught one person out of the group has went to a fire within 7 days. So I don't know what it is, but they've been running some stuff. So here's the things that I think the top 3 priorities is, outside of them already knowing how to turn it on, carry it, basic things, is whoever has the TIC has to do some form of what we call a tactical 360, which is a size up. You have to incorporate thermal data from the exterior view and the interior view. Size up is a continuous ongoing evaluation of incident priorities, not just exterior views, exterior and interior, depending on the incident, what we're looking at. We recommend that they use the BAG acronym, been, at, going. Where's the fire been? Where's that? Where's it going? And they use the camera after looking at that building or environment with their training first, training before technology. They use the camera and they locate the hottest area of the building based on the data we teach them to look for, such as thermal bridging, non-uniform heat signatures, or using those specialized application modes like survey mode offered by Seek. And then they look for the coldest areas. Why is it important they understand the coldest areas? Well, fire direction, spread, and travel, or isolated areas where people could have done exactly what we've been preaching in fire prevention and the Close Before You Doze campaign. We've seen buildings with 70, 80% involvement where they're ready to write the building off. And there's a couple trapped in a bedroom, absolutely fine. That camera can help you identify that, depending on the building. Also, you can see things like building layout at your initial scan, which should be part of your size up. The exterior view can also provide things like infrastructure. We can pick up stairs, joist spacing. We can look at things like knee walls. We can look at interesting roof features. We can look at a lot of things. And in many cases, we can see signs of structural degradation. You can't tell me 100% certainty when the building's going to fall in, but if you're trained in building inspections and thermography, you already know to look for that stuff. So if you take that data that we teach and use it to look for those things, you can identify when the building is already failing. And most importantly, hidden heat signatures, things that we would never think to look at, and all of a sudden we find a hot spot showing, oh my gosh, this building is energized because the cable line coming off that pole over there for some reason got energized, and we have 3 houses that are smoking. That's John Likely's call. You can look it up in our Size Up webinar we did with him. That leads us to determining the location of fire and level of involvement. Why is that critically important? How many YouTube videos, how many NIOSH reports, how many Maydays have you listened to, read, and they all said this: firefighters had difficulty locating the fire. And if they use the words encountering high heat and can't find the fire, that's one of the contributing factors right before a Mayday or line of duty death. The red flag, it's listed in the Mayday survey from Basil Ibrahim. It's in Project Mayday. It's in NIOSH reports. It's in the Preventing Firefighter Disorientation Study. Why is that critical? Because we're not doing it. We need to know where the enemy is so we can do 2 things in our initial entry scans, ladies and gentlemen. Your incident priorities can be broken down into 2 critical areas. Where is my line going for fire attack? And where are my search priorities? If I know where the bedrooms are through that Size Up, through my training and knowledge, we know that firefighter rescue survey shows that 45% of people are found in bedrooms. I would prioritize that unless I have other information. You know, circumstances dictate procedures, as John Norman says. But if I can get those 2 critical things after determining all of this, I have an incident action plan like no one else has. You can take the incident safety officer course and you can take all that valuable data. You can take smoke reading, which I recommend you do. But if you don't understand building construction, fire dynamics, and use this, you are missing the boat. Take these 3 things that this person asked about and use that as you size up the building, and then apply it. And do me a favor, when you're moving through the environment or you're walking around the building, put the camera down. Don't be staring at the camera when you're moving. And please don't be a narrator. Don't hold the camera and tell the firefighter what to do. You just took a 2-person crew and turned it into a 1-person crew. That's not fair to them, and that's not what that was designed to do. And that is our last question. So we have a video to demonstrate why using it during size up is important. This is a large amount of fire, but we teach that you should scan the building from low to high. I want you to see what Chief John Likely finds when he starts low. Single pane glass, Youngstown, Ohio. Heat transfer through single pane glass occurs much easier than double pane. And then like where I just left in Florida, good luck with hurricane glass. That's pretty tough. This is critical. He could have burn through, he could have a basement fire, but it's a large amount of fire. In front of him, he saw in the A division, which usually would cause us to candle moth, look at that first. But because of his skill and his knowledge and experience, he knew that he should start from the lowest level of threat, or to quote my instructor, Rob Foreman, fire above you will hurt you, fire below you will kill you. I have some very smart people in my cadre. I'm thankful to have them. Listen to your people, learn from them, share the information that we shared with you today, and take these resources we have here. This link on the left side is, after this one, will be 26 hours of webinars on one link. You can go through and pick which ones you want to watch. And then that QR code on the right that says webinar resources. This webinar, as far as the presentation, a go, no go presentation for the person who asked about go, no go. I have an entire presentation on there you can view for free. Data about 1408, lesson plans, all in that folder, organized, uploaded, ready to go. Why? Because you deserve it. Because you're risking your life You're giving away your time. You gave time with us today, and I hope and pray you use it and make the fire service better for it and get home to your family. Thank you for your time. Jordan, I turn it back over to you.
Okay, we actually received 2 questions in the chat. Do you have time for 2 more quick questions?
I have time for anybody who's willing to ask a question for nobody from North Carolina. Please go ahead.
Awesome. So Andy, I know that you provided some video resources, educational webinars, including, Thermal Imaging 101. You provided the QR code for that, and the Thermal Imaging Tips for Success, among some other evaluation criteria webinars. However, this person asked which of your videos is best for introducing volunteer firefighters to the use of thermal imagers.
They go to our website under the blog and look under the thermal imaging resource document. There's 2 there for departments that don't have access to TIC resources, absolutely free. And it goes through the steps. It mentions several simple short videos. And then if you look, the webinar it links to our YouTube channel, which is listed right here on this page, Insight Training LLC. The videos are organized by playlist and subject matter. I highly recommend that any department that needs free training resources go under the webinar playlist and look. There is right at 100 hours of webinars of various topics on there. But I would recommend they look at Thermal Imaging 101 first, Thermal Imaging Tips for Success second. There's one on there called Introduction to Tactical Thermal Imaging that we filmed in Dallas, Texas. It's an hour long. And then they start breaking down things like size up, fire attack, search, all that stuff's listed in there. And we have some specialized ones like special guests, like we had Webb Marshall on lithium ion and the dangers of incorrect TIC use, Joey Baxa with the one on Mayday prevention, tons of stuff. But start with the basics and work your way to the skill sets, just like we listed in the T10 key concepts. So if they do that, they will gladly have a lot of resources and a lot of discussion points, and hopefully they can develop that and use that in hands-on training.
Awesome. Thanks for answering that. And then the last question in the chat is, what do you think is the biggest misconception you have seen between a situational awareness camera and a decision-making camera?
Easy. They think a TIC is a TIC and they can use any TIC to do anything. And that's the most dangerous misconception out there. Otherwise, we wouldn't have firefighters using cell phone cameras in fires. I've seen cell phone TICs being carried into a burn building. I've seen industrial cameras meant to inspect automotive components that were $300 that looked like a fire service camera that was $500 fail in a fire because it wasn't made for that. They think a thermal imaging camera is designed to do anything. It's not. There are thousands of models of cameras. And when you look at situational awareness cameras, the biggest misconception is that that camera will do the same as any other camera out there. And I'm sorry, ladies and gentlemen, I've been in life a little bit now, and this is my 50th year on this earth, and I've made a lot of mistakes. One of the biggest mistakes I've done is when purchasing anything, not just a TIC, is not doing my homework and buying something based on price and not performance. You need to look at both. It can be a good price, but is it going to give you the performance? Look at the performance of the actual device, test it. That's what's missing. They turn it on in an environment like we're sitting now, and they say, oh, that image looks good, let's buy that one. That is a horrible way of testing a camera because it's not designed to work in an ambient temperature environment. Situational awareness cameras, we're producing a lesson plan that we published in 2026 for any department to test them on a simple model of helping your firefighters stay oriented and regain orientation. If a situational awareness camera cannot do that, it should not be in their hands. If they can't see 7 to 10 feet minimal, it should not be in their hands. And that's going to hurt a lot of feelings because when you look at a lower resolution camera, most of them not doing very well, especially when you add smoke and moisture. You need more pixels and you need a higher refresh rate that keeps up with you when you're moving, which is why mixed gain mode works so well in a seat camera, and help firefighters see the things that could harm them or help them. Whereas Dr. Gastaway says, see the bad things coming before they get a hold of you. But I would say just get an education about the device, test it, and then find out if it can actually do what it says it can do. Do your homework. That's what my advice would be.
Awesome. Thanks, Andy. That concludes all of our questions for our Ask Andy Q&A. If anyone has any further questions about what Andy went over in this webinar, you are welcome to reach out to Andy directly or myself, and we can get those questions answered for you. We will also be sending a recording of this webinar out to everyone who registered, so you should be receiving that today, sometime a little bit later. Thanks, Andy, again for your time, and thank you again for everyone joining us. Andy, if you have any closing words, go for it.
Just continue to educate yourself, share knowledge with everyone else, and do the world a favor. Lift people up, don't beat them down. The world needs more people like the fire service that wants to help people and not hurt them. Get out there and help the world. And we appreciate the opportunity of you guys listening to us today. Jordan, thank you for your time. Thank you to Seek Thermal for sponsoring these. And we hope these are valuable to you. Take care.
Awesome. Thanks again, everyone. Thanks, Andy.
Bye-bye.